go back. Let's go ahead and talk about this. Who has one way? Who has it? Wait, yep, go ahead, Francois. Quiet. Quiet.
0.7% plus 64.3% and I divided by 2.
Okay, to find your what?
To get like the
P hat?
The P hat.
Okay, so you said P hat. What he said was you take these and you average them because P hat's smack dab in the middle. What'd you get?
0.705.
705. So what you're saying is, I know that to get to these folks, I take my p hat, I subtract my error, take my p hat and I add my error. So that means that if I take these two numbers and I average them, smack dab in the middle is p hat, right? Because I started with it, I subtracted my error and I added my error to get these numbers. So p hat smack dab in the middle of them, average them, you get 0.705, and then how'd you find your error?
And then I took my p hat and I subtracted from the 0.643.
My lower?
Your lower.
Mm-hmm.
And got 0.062.
Great. Who did it the other way? There's a second way of doing it. Who did it the other way? Go ahead, Destiny, what you do?
I basically did like the opposite. So first I started off with 76.7, subtracted 64.3, and I got 12.4.
So what she's saying is that there's 2e from here to here. This is 2e. So she said that her error is equal to 0.767 minus 0.643 divided by 2.
Well, yeah, I did 12.4, then I divided by 2. Yes, the same thing.
And you got 0.062. So that's what she said. So there's 2 errors between these two. So to get from here to here, you have to add. E twice. So the distance from here to here is 2e. So she found e first, and then you did what?
And then after that, I just took the lower, and I added 6.2. And then that's how I got it 705 or 7.
I'll do the parentheses plus e. So 0.643 plus 0.062 to get 0.705. So either way works, right? So this is option 1. This is option 2. Both of them totally work. It's kind of cool to figure out yourselves, right? Okay. Here are the general rules if you just need to find one or the other. Right? Like you were saying, the p hat is the average of the upper and lower limits. The margin of error from the upper to the lower is 2 e's, so you divide by 2 to get 1 e. You should probably write this down somewhere if you might need them. Or if you know it, then that's fine too, either way, as long as you are comfortable with that. All right, moving on in 5, 4, 3, 2, 1. All right, so let's get a reader for this one. I can't figure out something to read. How about Alberto? Go and read for me.
Private schools. The proportion of students in private schools is around 11%. A random sample of 450 students from a wide geographic area indicated that 55 attended private schools. Estimate the true proportion of students attending private schools with 95% confidence. How does your estimate compare to 11%?
Great. Everybody right now, write down your N, your P hat, and your Q hat, and your critical value. Write down those 4 things. Write them down. We're going to make sure you're writing something down. We won't talk about whether it's right or wrong. We're just going to have you write them down. Your N, your P hat, your Q hat, and your critical value. Write them down. Find them.
Yeah, if you have something. One
Okay, so who fell for the 11% kind of, what do you call it? Tricky part, the tricky 11% thing. So the proportion is around 11%. Is that a sample proportion? My p-hat is my sample proportion. Is the 11% from my sample?
No.
It's not what I got from my sample. So that is not your p-hat. P-hat is your sample proportion. It has to be from your sample. So it means it has to be out of your n, people. So the 11% is not your p-hat. That's just a distractor there to confuse you and mess you up. Your p-hat, you got to find that from your sample. Random sample of is 450. 55 of them attended private schools. Aha. Is 55, is that a percent? Does it say 55%? So how do I know it's not percent? It doesn't have the percent symbol after it. Everybody on board? So my 55 is the number of people out of n. So you take the 55 and you divide by n to find your p-hat. So what's my n? 450. What's my p-hat is 55 out of 450. What's my critical value? 95% confidence level, 1.96. Great. Everybody do it. I'll give you folks 3 minutes to work on that. Listen up. Isla, can I explain what you did? Isla, go ahead.
Well, I found the decimal value for p, and then I found q by for p hat. Then I found q by doing 1 minus p hat, and then I found the margin of error by doing the 1.96 times the square root of the p hat times q hat divided by n, and got that to 3 sig figs. And then I found the range of, or the values for the confidence interval by doing p hat minus the margin of error, and then p hat plus the margin of error. And then for the confidence interval, I converted them to percentages because we're comparing it to a percentage. And I found that 11% falls within the confidence interval that we got.
Good. Everybody on board with that? So 1% seems fine because it falls right inside that range. Okay. Oh. You can also use it as a decimal, it's fine. You would have had right, so as a decimal it would be these numbers here. 0.0918 point, yeah. Oh, that should be, it'd be 92.
Oh, the screen turned off.
Oh, it must be 7 o'clock. Okay. Great. All right, so should time that better. Okay, so a couple of things to think about when you're analyzing polls. One is the sample should be simple random sample. In other words, if you take a bad or biased sample, you're going to get garbage. Right? So that totally makes sense. Second thing to think about is the confidence level should be provided, sample size should be provided, and for the most part, the quality of the poll results depend almost entirely upon the sampling method and the size of the sample. It does not have to do it doesn't have anything to do with the size of the population. So that's a super common misconception. Right? What people often think that if the poll sample size is really small compared to the population, so in other words, if I took a sample size of 400 people, or even 1,000 people, took a sample size of 1,000 people, they think that it's fine if my sample is, if my population is maybe 1 million people, but not okay if my population is 2 billion people or something like that. The population size doesn't have anything to do with how good your sample is and how accurate results are, except for the fact, this one fact. If I take a sample of people from California, take 1,000 people from California, it's going to be pretty easy for me to take a good random sample of 1,000 people from California. If I try to take a sample of 1,000 people from the entire world, that's a lot harder to randomly pick 1,000 people across the world. So that's where it gets a little bit harder. Is as long as you can get an accurate, simple random sample across your whole population, then that's fine. But that tends to be the difficulty. So very often we want to try to find a sample size. The question becomes, how big of a sample size should we take? And why do we do this? This comes up for one major reason, which is very often we want to have an error. Hold on a second, I'm not ready for that. Take that back. We want to have an error that's only so large. Like I want to find the approximation within 1% or within 2%. I want my error to be a certain size. So what happens is we take a look at this equation for error. If I look at this equation for error, what's error made out of? It's made up of my critical value. I can't change my critical value. That's fixed by like science. I mean, it's already in the distribution. It's on that table, right? You can't change that table. It's been out there for the world. It's already there. All right. How about my p hat and my q hat? Well, is it ethical for me to say, hey, I need my p hat to be higher? Say yes. I need my p hat to be higher. Say yes. Can I go around and tell people to say yes so I can make my p hat higher?
No.
No, it's totally unethical. That's completely wrong. So you can't do stuff like that. So I can't mess with my p hat and my q hat. Thank you for the comic levity there. However, I can mess with my n.
Morally reprehensible.
I can ask more people and change my n. So it's the one thing I have control over. So I can ask more people. The bigger my n, see how n is below? Like my error is something divided by n. So the more people you divide by, the smaller your error becomes. So the bigger my sample size, but the bigger my n, the smaller my e. So if I want to control my e, what I can mess with, the only thing I can mess with is my n. So if I solve for this, if I square both sides, and then multiply both sides by n, and then divide both sides by e squared, I'll get the equation on the bottom. Incidentally, this is at the top of your page, correct? I need everybody to write an alternative. So the top of your page, next to that, write this one in instead. This is a better one. Critical value over E squared times P hat Q hat. Anybody good at math will say, well, that's the exact same formula. The difference is that when you take critical value and divide by E first, and then squared, you're going to give yourself a nice, big, solid-sized number, and then you're going to square it and get a better large number, and then divide and do this. If you leave it with the first one where you take your critical value square and divide by E squared, your E squared ends up being this really, really tiny number, and ends up being a total nightmare to kind of work with. Because then we're dividing by, that's where we get that 4.14 times e to the negative 5 or some garbage like that, and we want to avoid that. So that's why we're going to do it the other way around. Okay, so now I lost the other screen, no problems. We can work with that. Poor people at home, they're going to get sick from getting moved around the whole time. Okay, let's try that again. Good. Okay, another thing to point out is, so here's the thing. We're trying to figure out what sample size to take for my survey so that my error is within a certain amount. I have not taken the survey yet. I have no idea what my p-hat and my q-hat are going to be. So we have two options. You can either take a previous survey or previous study and use their p-hat, like a similar one that you think might be about right. Or, if you don't know p-hat and q-hat are, just use 50-50 for p and q. So just use 0.5 for p and 0.5 for q, 50-50. So those are, that's what you would do if you don't have an example for p-hat. Okay, another quick question is writing off rule. So first of all, say I find my n, and my n is 237.164. First question is this: why do I need to round? I need to round up to the next larger whole number. First of all, why do I round it off? Only one person knows why I round? Destiny, why do I round?
Because you can't have 237.104 per person.
Right. I can't have 0.164 of a person. What am I going to do? Like 237 people plus an arm? Right? You can't do that. So first of all, that's why you have to round off. Why do I need to round up? That's the second question. Why does it have to be up? Yep, Molly?
Because you're looking to find the minimum.
Yes, I'm trying to find the minimum. If I'm trying to find the minimum, that means I need at least 237.164. If you go to a store and you buy something at $237.16, you can't give them $237. That's not, this is a minimum you need. You need to give them $238. Do you know what I'm saying? So this is the minimum you need. It means you have to have at least 237.164. 237 is not enough. So you need to round up to 238. All right. So here is an example. We're going to do this one together, which means you need to write in here on your sheets with me. Middle of the page, right here. Good? Everybody with me? Middle of the page? Okay. Drew, go ahead and read it for me.
Many companies are interested in knowing the percentage of adults who buy clothing online. How many adults must be surveyed in order to be 95% confident that the sample percentage is in error by no more than 3 percentage points?
Perfect. All right, so I need to find my critical value. 95% confidence level. That means that my critical value is 1.96. Everybody okay with that part? I think we're familiar enough with that. My error by no more than 3 percentage points. So it means my error is 0.03. Either we will say the error by error blah blah blah, or we might say within. You find within is your error. You folks remember before we did that whole part about driving to Oakland Airport? And we said, okay, well, I think it's going to be, that would actually won't work. Okay, say you go to the fair. Have you ever been to the fair? And the guy says, I will guess your age within 3 years. If he guesses that you're 20, within 3 years, what does he get? 20 to what? From what to what?
17 to 23.
Yep. 20 minus 3, 17, to 20 plus 3, 23. Within 3 years, that's his error. 3 years that he gets. Do you see what I'm saying? So you find the word within, you find your error. That's what you're allowed, plus or minus. So within is your error, or it'll literally say the word error. Good. Now, the first step is okay, we're going to assume we're going to use 66% as my p hat. So my p hat will be 0.66, which means that my q hat will be 1 minus 0.66, 0.34. So I'm going to plug this in here, and I'll get my n is equal to 1.96 over my error, 0.03, quantity squared, times p hat, 0.66, times q hat, 0.34. And again, work from the inside out. So we'll do this one together. Does everyone have this written down?
Yes.
5 seconds. 5, 4, 3, 2, 1. All right. So I'm going to do 1.96 divided by 0.03. Enter. I'm going to raise that to the second power. And then I'm going to multiply it by p hat and q hat times 0.66 times 0.34. I will get 957.84. 957.8 equals 957.84. That's going to round to 958 people. I have to round up, right? 958 people. So you're all doing this on your sheets, correct, with me? The next one, let's look at B. What about B? Here it is prettier too, by the way. Okay, now we'll go back to B. See, they did the other one. It's hard to do it that way. So if we do B, now we're going to say, okay, my n is equal to my critical value, 1.96 divided by E, 0.03. Squared times 0.5 times 0.5. I don't have an estimate for P and Q. I'm going to use 50-50. So now I'm going to plug those in. I hear clicking. It means people are doing it. That's good. And I'm going to get 1.96 divided by 0.03. Enter. Squared. And multiply that times 0.5 times 0.5. I got something you got. 1067.11. 1067.11. I need to round up because 167 people is not enough. I need at least 167.11. So I need 1,068. All right, you folks have got lab number 4 to do. So lab number 4, everybody find your error, find your critical value, find your p hat for the first part. This is prettier, can you get it? Find your critical value. Find your error. Find p hat. Find q hat. And find n. Remember, you find the word within, you find your error. Take a look. Destiny, can I explain what you did? Destiny, go ahead.
You start off by getting your CV. So since it's 95% confidence, we get a CV of 1.96. It says it would just be accurate than 2%, so RD is 0.02. Our p hat is 0.4 because it says the study shows 40%. The opposite, or 1 minus p, is 0.6. And then when you plug in your formula, you get 1.96 over there, yeah. And then you just 2304.96. Since you can't have 96 per person, you round up to 2305.
Great. Okay, everybody do the second part if you haven't done it already. Good. Folks, listen up. If you want to go home today, listen up, or else you're going to stay until everyone's quiet and he explains it. Go ahead.
So your 1.96 is your critical value, then your 0.02 is your E. And then it's basically the same thing as the other one. The only thing you change, since they're not giving you any information, you just use 0.5 for both. And so you solve it out and you get 2401.
Okay, good. All right, great. That's it. Have a good day. We'll see you folks on Thursday.